On yesterday's video, I showed how you can test capacitors leaving the common connected on dual capacitors. Today I'm showing that on regular capacitors, plus a whole bunch more on this video. Hope you enjoy it, as I think there's a lot in this one for you. Hope the information and video experience serves you well. Welcome back to Kung Fu Maintenance, where I show you how to make the most likely repairs you'll need to make in your lifetime. If you'd like to get the latest videos, subscribe and then hit the little bell icon right at the subscribe button, and it'll notify you of any new videos when they're released for you. Welcome back to Kung Fu Maintenance. We'll run another round of fun on these capacitors and checking the electrical side, doing the preventative maintenance on a little bit cooler day, a little overcast, and just gonna, get things while I can. Got one with no cover over here. Fixing that up. So straight down. Making things as right as I can. Alright, welcome back to Kung Fu Maintenance. We're doing the preventative maintenance on this unit, and it's missing the cover. Someone needed to get into the compressor. I had someone ask me the other day on the capacitor size, couldn't you just look at the compressor? And the answer is no. A lot of them aren't labeled. I'll show you on this one. You take a peek inside here. Discharge the capacitor first. The capacitor holds a charge in it even after the power is disconnected. Here's a Goodman. It's a 10 SEER Goodman, and so you've got all this different information, unit, model, got your wiring diagram, but none of them tell you the size of the capacitor. And if you peek inside here on the compressor data plate, which is on the top of the unit, it's hard to see in there for one. But it does not tell you what size capacitor. It tells you the model number, but I already know these units. They take a 35. But let me see if I can insert it further so you can see that data plate, and that it does not tell you the capacitor size. So I'm try to get you a clear view. No capacitor size. Okay. Anyway, we're going to be testing out these, and what I showed previously is that we don't have to disconnect the common side. So this is common, this is common. All we need is the start wire for the fan. That's the start, just like the compressor start. Usually labeled HERM on the capacitor.
Take the compressor start, and then one side of the hard start kit. And we can test the hard start kit, and we can test the capacitor, and this could speed up preventative maintenance if you're going through a lot of units. So now I can test from common to start for the capacitor, and this should be 35. See if our capacitor is weak, so we're going to need to replace that one, and then testing from
common
capacitor to the fan wire. That's kind of the start, and that's weak as well, 4.63. 4.75 is intolerance. So we need a 35 and a 5, and I'm switching over to the Titan Pros. So I'm just glad to be doing this ahead. I'll be disconnecting those commons anyway. So here it goes. This originally would have had a 35/5 dual cap. The common on a dual cap is connected internally. That's why we're using a jumper wire to mimic that same operation, which has some advantage in future maintenance in that a lot of times it's just the fan motor that goes out and this fan capacitor that goes out, and it's a lot cheaper to just replace that one capacitor if that's all that was weak. So just a little method of maintenance. The other thing is then also you're not having to stock so many different sizes. You know, if you want to stock the 35/5 as a dual cap, that's fine. For me, I like being able to split them off in this way. Okay, here's our fan capacitor. That's all set. Okay, now we're going to disconnect the 35. And the other thing is we don't want any loose connections in here. Nothing but tight connections. All right. There we go. And test that hard start kit as well. Went through doing, it was the other day doing some testing on the hard start kits. There's not a lot on them on how to test them, so I went through and tested 5 brand new ones. Showed that the capacitor was about 50. The hard start kit is quickly taken out of the circuit on these hard start kits with a little, it's like a temperature, I forget what you call it exactly.
relay. Stands for positive temperature coefficient.
You know, after
relay.
half a second or a second, it just gets taken out of the circuit. So you only want it for a brief moment, and what it does is it changes the phase angle of the incoming power. So we got 47, so that's good. And I don't see them wearing out as much as often because they're taken out of the circuit so fast. So got everything new here. Here's our commons. Here's our common jumper. And then our hard start kit. So I don't see these wearing out too much. I've heard people say that they don't like these hard start kits. I like them. They say that because if the unit, they say it doesn't reset, but really you want like a 5-minute delay on your units from starting. If the unit's turned off for any amount of time, you want it to delay, and then that way it doesn't start in an unequalized state. So it should give it enough time to reset. But there is some thought that that these might not reset. I've not had that happen or not had a problem there. I'm kind of using the hard start kit in a different way than most people use. A lot of times people give the hard start kit a bad rap because it's used on old equipment to keep a dying system alive, and that system's already dying. And so, you know, when it fails, then you know, the thought is that, let's put this all back together here. Not the easiest thing in the world to mess with. Someone needed to get in there to cool down the compressor. Anyway, what was I saying? The thought because the system's on its way out already, like a compressor's already weak, then some people give the hard start kit a bad rap. I'm actually using them in a different way. I'm using them on new systems to ease the load on the compressor, ease the load on the capacitor as well. And the capacitor isn't pulled on in the same way or pushed on in the same way. The whole system really, because what it does is changes that initial phase angle when it initially starts. That's why someone didn't put it back last time. But the whole difference was probably it was 100 and something degrees out instead of like now it's reasonable. This is a pain. Man, that's crazy. It's probably less work to take the lid off the unit and cool move it down this way. There's a lot that can go awry here. Don't like this at all. Yay. That's crazy. Crazy. Alright. I don't think I'll regret fixing that, but you never know. At least I set it mostly right. Now we'll reconnect our conduit here. I don't think that one's gonna reconnect. I hate to see so much pressure put on this in this way. Okay. There's that one. Okay. And then this one is Edison box. Oh, I've been watching these Edison boxes. I don't know if you remember the unit I had where they had one of these yellow wires was connected to the start wire on the capacitor. It's like, that's not right. And I called in Edison and they came and looked at it and they left it that way. And when I look at these, I see the yellow wire coming to one side of the contactor and the other yellow wire going to the other side of the contactor, and then the two black wires going to the bottom. So it's just bizarre to me. This one goes to here, and then this one's coming to this side. So yeah, I know that thing is wired wrong. It's like, what do you do with that? Like, call Edison again, have them send a different tech maybe. I don't know. I know the thing's wired wrong. I know how to fix it. I could just fix it, but it's not my equipment, you know. So yeah, it's the annoying part. It's the way it is sometimes. This should be mounted somehow, but even their Edison's box steel is so weak that it's pretty much broke off. I don't really like it where they have it either, because it's touching the suction line. Oh god. Yeah, these are plastic pieces of junk. Try to get it off the ground, get it into a better spot. Alright. Better already. Get it at least off the ground. Want it on the crazy. Probably have Edison come rid of it. It's not in use anymore. Silly thing. Alright. Now we're ready to plug things in. Okay. This one should have a cover in there. It's missing. It's more important to have this cover. Let's see if I have that cover in my bag. I was carrying one around for a while. Ah, shoot. Nope. That one. Again, it's not critical, but it's going to test this unit. Let's fire it up and see. Yeah. Fan spinning the right way. Good, good, good. And I can put it all back together. I'll need some screws for this bottom panel, but at least the panel's in place now. Way better than what it was. Now I can see where they had mounted the Edison boxes on the front here. It's better than it blocking off airflow, but this thing's just, you know, they're not built to last in the desert. If you're gonna do it, you're gonna have to pick a better material. A better way to mount them. Lined up. There it is. I think. Where are you, buddy? Can't see it. That's how it is. Sometimes it can be really tricky. Okay, a bit better there. All set. All right, on to the next ones. Okay, just got this cover. I'd like to, maybe I'll find one later, but I'm gonna go ahead and close it up since. When I was working on just turned on. Nice and cold. It's great. Working good. These I'll save. Little shock absorbers. Hey, there's the plate I needed. Remember that first one? Told you I needed one. Well, we got one now. This stuff.
bucket. Here we go. Yeah, we got the right cover for this deal. Make that a little bit better. Yeah. The way it is. The way it should be. Alright, all the trash. Goodness gracious. A quick search on my YouTube channel of whatever your maintenance needs are, you should find a bunch of different material that'll be helpful to your maintenance needs.